Hi, my name is Syed Abidi, and I'm an applications engineer here at Iconics USA, manufacturers of electrical safety test and compliance equipment. In this short video, we will explain you two very important electrical safety tests as called out by most test standards, the ground continuity test and the ground bond test. And as the name implies, both these tests are required for a Class 1 product that incorporates a safety ground circuit. So let's take a look at each of these tests and understand how the ground circuit is tested.
Okay, so let's take a look at the ground continuity test first. The ground continuity test verifies a continuous connection between exposed conductive parts and the ground of the power cord on the product under test. In the image on the screen, we have a Class 1 product on the right side and a ground continuity tester on the left side. I'm going to just mark the ground pin of our device under test with a green marker. And when a continuity test is performed, a low current DC signal is applied from the chassis of the product to the ground pin, or vice versa. So we're going to show our DC signal with a red line going through the ground pin all the way into the line cord, all the way through the ground circuit. It's going to experience some resistance, but we're not too concerned about that for the ground continuity test, because what basically we're trying to measure is continuity between the ground pin of the line cord and the chassis, which is going to verify that the ground circuit is continuous. And that's what the ground continuity test is all about, just to verify that a continuous ground connection exists on our products. And few other things to know about the ground continuity tests are that it's usually required as a routine production line test and is often performed along with the high-pot test to ensure ground continuity.
Okay, so now let's take a look at how simple it is to actually perform a ground continuity test on a Class 1 device that has a ground circuit. The device that we're going to test today is an LED lamp with a 3-prong line cord, and we're going to take our continuity check lead, which is right here. We're going to connect it to the ground pin on the line cord of the device, and then we're going to take our return test lead and connect it on a chassis point on the device under test. And as you can see on the tester, the green light turns on, which is indicating that this device has a continuous ground circuit.
All right, so let's take a look at the ground bond test and understand how the test is performed, what is really tested, and what are the important test parameters to keep in mind before running a ground bond test. So first of all, the ground bond test verifies the integrity of the ground connection between exposed metal and the ground wire of the power cord. Now the key word here is verifies the integrity. Remember that earlier we learned what the ground continuity test does, that it only verifies that a continuous ground connection exists. Now looking at the ground bond test, it verifies the integrity, which is what makes the ground bond test the more stringent of the two. So looking at the circuit for the ground bond test, on the screen the left side is labeled as GB for ground bond, the right side is the device under test. So when the ground bond test is performed, high current in the range of anywhere between 5, 10, 15, 20, all the way up to 60 or even more is injected into the ground pin of the device's power cord at a low voltage anywhere between 4 to 24 volts. And again, all these numbers are always called out by the standard that you're working with. So high current is injected into the ground pin of the product's power cord, which flows through the chassis. So I'm going to draw that path of the current using a red pen. Current flows through the ground circuit, makes its way all the way back to the chassis of the product, which is where it's measured via the return connection of the ground bond tester. Now, when this current flows through the chassis of the product, a voltage drop occurs, a very small voltage drop. And that voltage drop is then used to calculate the impedance of the safety ground circuit, which shall not exceed 100 milliohms or 200 milliohms or whatever number is allowed by the test standard that you're working with. So the resistance can be then measured using the small voltage drop, which is usually in the millivolts range, divided by, for example, let's pick 10 amps for our current. This will result into a very small resistance value. That's how the ground bond tester measures and calculates the resistance of the safety ground circuit and displays a milliohm number. Now, obviously, the ground bond test is used to make sure that the safety ground circuit of a device should provide a low impedance path for any fault currents that may flow on the chassis of the product. Also, it's good to remember that the ground bond test is allowed using either an AC current or a DC current, but AC is more commonly required by most test standards. And another important thing to remember about the ground bond test is that some ground bond testers utilize a 4-wire measurement technique, which is basically separating the voltage and the current conductors to get a more accurate reading. So anytime you hear the term 4-wire or Kelvin connection, it's just a measurement technique that allows to measure a more accurate value of the product's ground circuit. Next, we will take a look at the ground bond test being performed on an actual device in our lab.
Okay, so now that we've learned a little bit about what the ground bond test is all about and what is really being tested, we're now ready to actually perform a ground bond test on our product. Again, we have the same LED lamp that we're going to test. The line cord of that lamp is plugged into the adapter box, which is connected to our ground bond tester. And then we have the return connection on a chassis point of this lamp. On the tester side, I've programmed a 10 amp ground bond test at 8 volts and 1 second dwell time. And I've set my high limit for the resistance to be 100 milliohms. So now when I run the test, if the measurement exceeds the 100 milliohms, this should result in a failure. And if it doesn't, then we will have a pass ground bond test. So as you can see in the screen, the resistance measured was about 78 milliohms, and that indicates a pass.
So now let's take a look at why the ground bond test is the more stringent of the two test types compared to the ground continuity test. In our example, we will show you a piece of cable with multiple strands, and if we were to cut out all strands but one and perform a continuity test from one side of the cable to the other, it will result in a pass. This is because the single strand of wire that's intact will be enough to provide continuity from one side to the other. Whereas if we were to perform a ground bond test on the same single strand of wire, it will most likely heat up and melt, since it will not be able to handle the high current flowing through it. And this is why the ground bond test is regarded as the more stringent of the two tests. Next, we will take a look at a ground bond test being performed on a paper clip, and you can see for yourself how it's going to heat up and catch fire.
Okay, so hopefully now you understand what the ground continuity and the ground bond tests are all about. If you still have any questions on this video, please feel free to reach out to us. And thank you for taking out time to watch this video. Also, stay tuned for all our upcoming videos on various topics on electrical safety testing. Thank you.